guys. So I'm Saatvik, and some additional information before we go ahead anywhere. Uh, for no reason, you guys would be asked to turn on your cameras or interact in any way. So feel free to relax, grab a cup of coffee, and all we'll be doing throughout this session is explore something called as Three.JS, what it is, why we could even consider talking about it, and just see what we can do with it. So that's mostly it. And let's dive in. Before we go anywhere, and let me talk about what Three.js is and why even we are talking about it, or how actually I stumbled upon it, to be honest. So I was actually looking for a personal website, my own portfolio I was trying to make, and while considering many options, they all looked very similar, to be very honest, and I was looking for something new. While I was in that search, I actually stumbled upon Three.js and considered while considering, actually, we realized that it's actually quite fantastic what they have done and what we could do with it as well. So personally, I am a software engineer, but I would say that I like to play around with things a lot. So in that hunt of curiosity, I would call it, I was exploring, like in my earlier 4 5 years back, I'd explored 3D objects and how they are made and basically what could be done with it, cinema 4D, etc. And having that little bit of insight into that, I feel helped a lot in exploring this. So during this session, what I'll be doing is whatever I have learned in the last, I guess, 1.5 month about this technology, I'll just try to distill it down in as few words as possible and share it with you guys. So consider this to be like a knowledge sharing session more than anything else. To be honest, there are a lot of things that 3GS has to offer, as well as that can be done with it. However, in my small exploration that I have done, I'll try to abstract as much of it as I can, and I'll try to give you the distilled part of it. So essentially, if you are able to see the screen, there are certain words: scene, camera, renderer, initial camera positions, listeners, objects, materials, etc. And let me segregate this for you further. So all of the first 1, 2, 3, 4, 5, 6, 7 things until lights are part of the initialization, and the second part is the animation function, which is what will be actually helping us make those objects that we have created on the scene move. So essentially, this is just a brief, I call it an index of what we'll be discussing via the code. But these are the things basically that we'll be talking about. So scene is essentially as simple as the baseline, the floor of the entire page that we are rendering. Camera as it is literal. So let's look at it this way. Uh, when we are trying to make anything in 3GS, it's typically referred to as making a scene or setting up an environment in a scene. And what they usually mean by that, it is typically very similar to how somebody directs a movie. So what you have essentially is a camera, an environment which you have full liberty to set up whatever and however, all inclusive from the floor of the ground to what objects are there on the ground itself, to as small as the fog that is there, or if there is any cloud, stars, etc. Like literal environments can be created. So since that kind of capability is there and the freedom of 3D, which doesn't restrict us to actual real world elements, it gives us a lot of freedom in this kind of a mesh environment or club together. So we'll try to look at it as somebody that, like, imagine that we are trying to make a movie and that is just being played in the web browser, and that is exactly what it is. So what we do is we set up the scene, we set up which kind of camera we would like to use, where we would like to place it, basically what we see, what is rendered on the screen. A couple of event listeners we'll do, but that is specifically for, since it's a website, there are certain things it needs to handle. So we'll just cover a couple of common do's that are there, let's call it. Certain objects and materials, basically all of the 3D part of it, that would be there. And lighting, because by default, the scene obviously would have no light. So every option of customization is there of lights as well for us. At the end of it, all of this once initialized, it's connected together via the animate function, and it actually lets us render those things in real time. I hope I'm making sense so far. I hope I'm not going too much into detail, so do let me know. If there are any questions, actually, to let me know. No need to respond. I promise you guys not to be interactive session. My apologies. So there's only one piece of theory that we will want to refer for this entire session, and which is this page that you're seeing right now. Other than this, we'll be talking about a couple of other interesting things like orbital control, or basically what these words are like. Orbital controls, arrow-based interactions, if we can do, what kind of interactive pages based on scrolling we can make, so on and so forth. It's fun ahead. But there's only one piece of theory. We'll just very quickly go over it, and we'll be ready for it. ठीक है. So essentially, there are two main camera types that are presented by Three.js. One is a perspective and one is an orthographic, as you can clearly see. There is primarily only one difference if I would like to elaborate. So essentially what happens is in the orthographic frame, the right one, whatever the camera will render, it will not be exactly 3D. What it will do is it will try to render the 3D object in a 2D plane. So it would look a little bit flatter. However, if you go for the perspective one, it actually, if this is the point of view of the camera and it is seeing this scene, it will let the object be smaller as it goes further away from the camera and bigger as it comes towards the camera, which lets us actually have a much more realistic view of for the viewer or the consumer of the website in actuality. So for most of the projects I've noticed, or even whenever I was trying to make, I went ahead with the perspective projection itself and not with the orthographic one. So just a personal preference, but feel free to explore both of them. Uh, Before I go ahead, let me share the link for documentation with you guys over this chat itself, and that would cover most of the things. Second. So now, once this part is understood, that perspective basically is just simply letting the object grow or reduce in size majorly, and rest of the nuances, obviously, there's more. But in a gist, if I were to crisp it down, this would be it. So moving on, let's dive in. Then I guess we'll just move on. So very quickly, what we'll be doing through the session is, as you guys can see, this link that I have shared. If you'd open it up, it contains a couple of resources for everybody's reference. It's just a collection that I had for myself and my own reference, and just sharing it with you guys in case it helps in any way. So the biggest source of documentation that I was personally referring so far, and I have been continuing to, is the Three.JS documentation itself. It's fantastically written. I have loved using it. It has been brilliant so far. If not for this, if there's anything that I am looking for particularly in something to implement, YouTube and Google has been of incredible help. There's tons of resources that I could look up to, and they were fantastically helping in each and every single detail. So I'll actually let me go into elaboration of this. So for example, this is the set of examples that are there publicly open source available all across on Three.JS itself, which is 3js.com/examples. Couple of these have animations in themselves. Couple of, and what we can actually do is we are allowed to open the GitHub code link, get all of these resources, every single texture, animation material, and use it to however we would like to use, for example. So, for example, check out this. This is a character that, if you see, allows different kind of animations as well. So it can walk, it can walk, run from idle, etc. And all of these things are customizable. And all of this is available on CJS, its GitHub itself. Mr. Dube is the person who has made this. So great thanks to him. So while we move on, what we'll be trying to do in this session is we'll try to make a small sample project to understand the basics that we were trying to discuss earlier in the live format PyB tool. And once that is done, we'll just check out a couple of advanced projects that I have personally found and I loved, and I would like to share them with you. So we'll just start with. Hope that works for everybody. And moving on. So very quickly, let me open up my startup project. So right now, what I'll do after this call is this is a sample starter project that I had created especially for this. So if anybody would like to try it out, it's the bare bones levels, plain HTML, CSS hooked together. For everything you need, basically the infrastructure of Three.js to just try out the 3D elements on UI. So let's dive in. The basic structure, there are, okay, of course, there's many ways to set up the project itself. But for the sake of simplicity itself, and since we are doing intro sessions all, let's consider that we'll just assume that we have a plain HTML file that we'll be working. But however, as the project grows, like for example, if you have more resources, more audio files, etc., it would be helpful to honestly have some sort of bundling or move this project itself to a module-based React project. We'll see an example of that towards the second part of the session. But in the first part, as a starter part, we'll just stick to the basic HTML rendering. So what this will allow us to do is we have a very simple project: one CSS file blank, one JavaScript file, and a CDN for the Three.js. In the CSS file, we have simply just made the margins and corners, basically everything empty, so that whatever scene we render takes up the full space of the monitor. Next up, exactly the same screen that we saw in that presentation. So what we'll be doing is we'll keep adding these things here and understand what they do and keep checking out what it does in real time. So let me very quickly open this file in my browser here as well, so that we can keep checking on what is happening. So right now, as we can see, it's rendering as empty. Since obviously the HTML itself is empty, rendering nothing. We'll try to move on here and add some things to the JavaScript part of it and see if we can make something happen. That's it. So like we just, okay, one more thing before I add on, I have a second screen here on which my part of the code is also rendering. So I'll keep referring left and right, just on information for everybody. So let's see. So let's set up the scene. What is a scene? What do we do? And why do we want to set this up? So let's see. If we check out this example that we were seeing earlier, if we see this black and white checkered ground, foreground base that is there, that essentially is what we would refer to as the scene. It may not necessarily have a base background. It most often is initiated as transparent itself. But if I were to put a texture on it or any color on it, it would be a flat scene rendering. So basically, this is the scene part of it. Where we are, the camera is obviously the camera. Whatever lighting we set up on this scene is surrounded. Basically, there are 4 or 5 types of lights as well. So, for example, there's hemisphere light, which can be used to emulate like sky kind of lighting, sun, moon, solar, like stars, even solar systems have been made. I saw a couple of examples. Other kinds of lights are smaller ones, like a point light or ambient light, even for example, or I might have a list of them. Let's continue. Let's discuss that later. It's not as important right now. So essentially, in this thing, there are a couple of more things. So there is a near clip plane and there is a far clip plane. What that essentially defines is what is rendered in the scene. So since the scene is infinite in all spaces and all dimensions and directions as well, uh, if we start rendering the whole of it, the browser may or may not be able to handle the resources resource wise. So it's kind of a prevention thing as well as we decide as a developer what we want to show of that scene. So the far clip plane literally is the far end of how much we want to render. Post that it will be either the hemisphere light or the background that we have set to the sky or some kind of background that is the last part of the shell. But otherwise, it would stop rendering post that. A near clip plane is basically how far the camera is from the scene. If this is my scene and my objects and this is my camera, it's basically the distance between them. More simple. If we look at the documentation of this very quickly and check out what a scene is, it helps to understand particularly. So essentially, where, as it says, it's where to be rendered. And while we set up the scene, it's a very small part of it. It is actually the base of it. So if while we are doing the scene, we will also set up the camera and renderer. Like we discussed, we are using perspective camera for our use cases. And let me. So essentially, we have initialized the scene here. We are saying that we are using a perspective camera. We'll check this out later in the docs as well, so that we understand what we are passing here. We are also setting up a renderer. What this renderer is essentially, it's like a hook kind of thing which helps web. It's an internal WebGL thing. We won't get into it. And why we are doing this is also something we'll discuss later. It's an additional feature just to help smoothen out the edges and improve the rendering that has happening. So basically, anti-aliasing is a feature that it provides by default. We're just enabling it and using it. There are multiple others we'll discuss in other projects, but for now, simplicity's sake, this is the basic setup. So what we have here is we have the camera, we have the scene, and we have the renderer. Okay, by default, okay, another thing that I realized, like while I was setting up a scene for myself and trying out my first project, what happened was I created a sphere and I created a camera. Now, coincidentally, I didn't know, but the initial position of everything is 0. So my camera was rendered inside the object itself, and I was not able to see anything. It took me some time to figure out that I have to move the camera a little bit back to make sure that I'm able to see what my scene is actually. So since everything starts at the same center point, it's important we make sure that our arrangements are also in that accord. So for that purpose, what we'll be doing is we'll be setting up a couple of basic camera positions, which is just simply setting up the Z value for this. Allow me. So since we have this camera object, it allows a position property with a Z element, X, Y, Z, all of them, anything we can set in however we want. But for the sake of this example, we'll be setting it up as type. So a little bit ahead of our object. Let's see. Let me add a couple of other things here and then elaborate as to why I am adding them or what is the need of it as well. Add a couple of renderers. We'll just set the render size to the Windows size in a bit. Perfect, perfect. Awesome. So now, one more thing. Now that if we try to save this and see what would happen, we have not added any event listeners as of now. Okay, correct. As we are able to see, it's only okay. Check this out. So I had a bookmark bar here, which I just hid. But because of that, the scene rendered, it took the size of this window, but now it does not have, since it's resized, it does not have the full information to update itself. So this is another one of the event listeners that we'll just be adding in the next steps to handle these kinds of edge cases. Currently, since we haven't set up the scene empty, we only have a blank screen, and again, we'll be adding things to it. So let's go ahead and add this event listener as well as a couple of elements to check out what it would look like. So we are very simply adding one event listener for window resize. Basically, if the window is resized, we'll just get that current value that it has changed to, update it for the renderer because it is the one handling all of the interactions as a proxy for us. Since the screen's dimensions have also changed, the camera aspect, etc., also needs to be updated a little bit in certain cases that starts morphing on the corners. So it's kind of a prevention for that, and we are updating the projection matrix. Now, projection matrix is essentially a function offered by the camera module itself. It just updates what is being rendered in real time so that there is no lag per se. It's a standard material essentially. There are multiple other ways of event listening that we can do. For example, you can set on scroll, you can set on clicks, key ups, key downs, particular keys. So for example, in one of the next examples, the advanced kit, we'll be checking out an example which allows us to map the arrow keys to let the character move in real time in your scene. So which was a fun example, honestly. So we'll check that out next. Now that we have this event listener as well, let me add a couple of just actually one basic shape and then see if it is getting rendered by chance. So right now we are able to see nothing because one other reason is right now, since the default plane scene, which is rendered transparent as well, it also is lightless. So we need to add light to it so that we are able to see our elements as well. So for example, I have added here a basic geometry cube, basic geometry sphere, which is essentially again inbuilt component provided by the Three.JS module library. And it takes certain set of parameters you can check out in the documentation what they are and why we are passing this particular one. But for me, I needed a simple sphere with this configuration. Basically, this is the size, this is the vertical sections of it, and this is the horizontal sections of it. So this will look like a disco ball, I hope. And there is a material, there's a cube. Let's talk about these things, what we are doing and why we are doing this. But let me do something here. Let me add some light to this so that we are actually able to see what we are trying to render. Allow me a moment to troubleshoot this. Right, we don't have any animation function as well. So let me, so this is a crucial part of it. We would need it to be there for it to run. So essentially what happens is the animate function that is there, it is running at 60 FPS while it is rendering at that rate. So it's called every time any frame is needed, a new frame is generated that has to be updated, etc. So we'll just simply call it a function, just say animate. What we need is actually request animation frame and it takes the function itself. Basically, we initially call this function once and then it keeps calling itself and keeps updating the values, whatever they are. All it is doing is calling the renderer, going into the render, and asking it to update the camera and the scene. That's it. And what we'll do is, since this is not called as yet, we'll just call it at the end once. Let's see if we're seeing anything. Oh, we have something. So what we have here is a scene which has a background color set to some value, which I think is a gray, I think 333. We have a sphere that we made, and our camera is actually not inside the sphere. So what I would do is, if I don't have this line here, as simple, I don't think it should render. See, so we would not be able to see any of our elements because we are actually inside that particular sphere itself. What is seeing is the inside of the sphere. There are other projects as well I would like to add that are able to do manipulations for the inside part of the sphere so that they make an animation where you are actually zooming into the sphere and then you go inside and there's another world in. So if those are beautiful particularly as well. Restoring the state for this. So now we have a sphere which has some sort of lighting on it and has certain colors. And as I discussed, these vertical columns and horizontal columns, everything. So where does this all come from and what is this? All of this, let me add, is a set of basic shapes is provided by uh, Three.JS. So if we would check out geometry, I think yes. So for example, this is the sphere geometry that we are using. The radius is the first parameter that we passed. Height segments, width segments would help us make this shape smoother or rougher pieces are need particularly. I like the disco ball, so I just tapped it. But all of it is configurable and you can understand what kind of constructor it has, so as to what it supports and what all can be done. Beautifully set up documentation, I would suggest that you guys check it out. While we do that, now that we have this basic project set up, let me see if we're missing anything here. Let me see if we could be able to animate this. So if we go to the code here and we say, okay, so most of the animations that happen are initiated at least in the animation function. So since our project is a smaller one, we'll just be doing them right here in the animate function. For the bigger projects, I've noticed people have added a function here hooking to something else, which is their main actuator. So just an FYI there. What we'll do is, since we know that we have some kind of sphere here somewhere, we have a cube. Yes, so we have a cube. Variable name cube. Let me think. So what we'll do is we will ask it to rotate. I think there is a rotation property. Yes, there is a rotation property that it supports, which can take X or Y coordinates. We'll just call it, say, increase it by 0.0. That's it. We need to do anything else. Yes. So we need to do this thing, all of this thing before the renderer is called. So whatever changes we'll write here will be updated by the renderer at the end. So let's try to save and see if this is making anything happen. I don't see anything happening. Let's see. What did we do wrong? So we have X rotation on. Can we also add Y rotation? We're rotating the scene. We're rotating the camera. Ah, beautiful. We have it. So right now we are able to see that it is rotating on both axes. I think it wasn't refreshed earlier. So, no way. So essentially, this is an empty scene on gray background. What we have. The sphere is provided by library itself. Everything is customizable. It's beautiful. Now, this is a very small project that is literally for this demo itself, but there are much more beautiful things that I have found that I would like to honestly share with you guys. If you open this resource link that I have shared in this chat, I have some much more detailed projects, and I'll try to talk about whatever I have learned exploring them and whatever I understand. So let's check out. I found a couple of interactive games. A lot of 3D artists have paired up with engineers to make their portfolios and artworks available online. So a big ton of galleries are also something that I would suggest worth checking out. So let's check out a couple of the best projects that I personally saw and see where we can go and how we can make them honestly. So let's see. So this is one of my favorites personally. This is a small gallery that was made, and another one I would like to show is this Bruno Simon. It's beautiful. So it takes a little bit to load. I'll just allow this to load while let's check out this Bruno Simon. So when I started exploring, I think this has some music. When I started exploring Three.JS, this is one of the first websites I came around to. I think it's lagging a little bit because of the no issues. So this Bruno Simon guy, he is one of the engineers who is also having a lot of resource videos that he has made up and is uploaded on his website. So I learned a couple of things from him actually, to be honest, because of him I got hooked to this. And I would just like to give a shout out to his portfolio. I recommend you guys check it out. All of these links are in the resources. So this one is at the last end. Feel free to open it out on your end. It might lag for me if I present it, but interacting it with it is, I would suggest, much better. So this one has vehicle controls with the arrow keys, sound controls with the audio support, physics with matter physics as well, and a speed control, I think, with shift. So you check out the entire thing. So basically, if you go right, there's a ton of his projects that he has done, other things on the left side. It's beautifully interactive and it's quite fun actually. So let's check out the right side. So basically, what he has done is set up the scene and having this. We'll do this kind of example in the advanced kit. We have a vehicle which is responding to as simple as event listeners. So this Vehicle moving is a event listener getting called on my key press, and it is just making the change of the object, basically calculating where the vehicle should be in the next step and updating the renderer to update the scene in real time as fast as possible. And it's fantastic. So check this out. If we go here, and we would like to open any link, it would open the project itself. And this is actually not the fun part of it. I would actually take you to the better part of this project itself, why I like it. So here he made a couple of games, which is why I honestly started checking out what this is. I have been trying to implement this physics for my personal project, and I hope I am able to get a good render out of it. Currently, all I have is very bad looking things crashing together, but this guy has made it brilliant. So there's a bowling alley, and it all works well. So the best part is we can set up interactions with each element and let that handle on itself. So the ball right now is still rolling and it will roll until the end of the frame is reached, vanish, but keep rolling until the infinity, honestly. So it's fun how it has been made and what can be done with it. And this is one small example of this brilliant guy. A couple of other things that people had done were as simple as setting up a small scene. Like, for example, this is a gallery art for presentation for one of the people where they have set up a outside scene as well using hemisphere lights particularly, and this particular box is using 3D elements that the artist had built. All of the artworks I was checking out, there's this one art piece literally which has scratches on it, like to imitate the real worldness of it. So the way how it can be done is actually incredible, is what I wanted to share with everyone in all honesty, and is what the purpose of this call is as well. So since this is a limited plane, we'll just move on to the next one. But I wanted to show you guys because of the light. So I think there's a toggle which changes day to night as well. I think, and let me try it. Takes a little bit time to render. Ah, yes, we are here. So now we are on the day mode. All of the lights are here. Again, hemisphere lights straight. But majorly hemisphere lights for the shadows and everything. And obviously there are internal lights, spotlights, certain spotlights here, a couple of reflections from outside. Beautifully done, and all of it is calculated by Three.JS itself for us. So, loved it. Another fun example I found was, so for example, this thing also does not have a window resizer, is why we are seeing this kind of thing. But if we do have added to that function as a event hook, it would take care of it. This was a fun game actually. So it's simply called Crossy Roads, and it's a game I remember playing long back, but built into something fun. All of this is made using Three.js. It's made using elements that are open source. So this project that you have is in this link itself. I call possible further. Feel free to try it out. Feel free to play. Certain objects, for example, here are crashable, basically, which he can go through, and certain ones he just can't go through. So, for example, the trees he can't cross through, and those kinds of customizations are also. Another fun one was imitation of that Android game that used to be there. So this one has that event listener, and see, we didn't have any issues. So for most projects, there is a small set of do's and don'ts that they suggest, and these are basically a couple of those. So this was one actually. Another thing to add. So all of this, since it is rendered on the browser's client side itself, it has a small memory, which is the native memory. If I refresh the page, all of the data will be lost. But until that happens, it is able to store the state, move on, and work with it. So one interactive long session could work out for most use cases, is what I found. So simply, this was a fun one if you'd like to try it out. Again, this has a spacebar and a mouse key event. So all of these that we are seeing right now, they don't have any other controls. What we are able to do is we are able to see a scene in 3D, but not feel that it is having that parallax effect or any of those nuances that enhance that effect or make it more immersive per se. And that is where other keywords like orbital controls and others that we read about earlier come in and what we'll explore as well. So let's check out a couple of other projects moving on. So there are smaller interactions that I found as well, and bigger games, etc. And since the community is so fantastic, I found this beautiful footer kind of animation which interacts to the mouse movement. And you can set it up however you want. And once it is configured, remove all of these toggles and let you're done with your website's footer. And all of CodePen itself has a big photos to menu hamburger animations, everything. And it's fantastic to see how kind of community support can make a small project and a small need make to be done so easily. Love this one as well. Moving on. Let's check. And this is a personal favorite. So this artist made a good scene, and it is gorgeous. I'll be honest. I'll just let it render while we open a couple of other ones. Another example I found of the matter physics, which I am actually recently right now exploring, is this one. So this one has this kind of control for mouse as well, which is actually orbital controls is what the word we use. So one kind of basically, let's say if the scene has to respond to this placement of the mouse on the screen, be it anyway, either by click or by plain movement to have that parallax kind of effect, it orbital controls really help us do that and achieve that. So this one was a good example of physics and how they are rendering the stats in real time is I personally enjoyed checking out. So this one is also towards the end of the document to check it out. It has a ton of other examples. So if you go here in the demo section, they have various set of examples that they have written, different kinds of collisions with the objects and materials itself, which we can use for our any purpose and replace the objects with whatever objects we like. Code right here. We can check it out. It's amazing. I personally loved working on Three.JS and making a small project. What I have been working on is a very tiny starter kit, and once it's ready, I'll try to share it with you guys. But it's been fun checking these things out. Do check this one out. I personally love this one. There are much bigger projects also, and so sorry, somebody saying something. Am I audible, guys?
Yes, yes, you can go ahead.
Oh, all right, all right. So a couple of projects that we have seen so far are the smaller ones, which were mostly in HTML, CSS, JavaScript itself. But there are a couple ones that I really like, which try to use React itself, and this is one of those examples. So this is a full-fledged racing game that they have built for no reason. It has a music, so if I start, I'll just check where is mute you. So they have a lot of music and a lot of interactions. So all the way from acceleration of the vehicle to it bumping and then making a sound, it bumping into different things and making different sounds at that level itself. It's beautiful. And let's check this out. I'll just start and mute this. So this is where it starts. There is an engine sound. It's beautiful. Do play this. I loved it. It has some zero gravity thing, so the car starts flying randomly. But otherwise, it's nice. If you try to bump into the train, which I have obviously, it doesn't go through and it like pushes it back so badly. But yeah, it has some kind of 3D thing and it has a lot of music and everything. So they utilize like literally the full potential of 3JS, and I have turned my car upside down. Let's see how do we reset this. R. Awesome. And see, this kind of controlling is also a plugin that is available. I will try to find the email message in the book later. I am not able to recall. But this is something that is provided as a library. So you can configure what variable you want and what values possibly are. So for example, this one utilized a button kind of key configuration, but there are ones with sliders that we saw on, for example, 3GS main website that we saw the examples of 3D objects. Those have toggles, multiple options, fully customizable. Check that out as well, too, guys. So this is a fun one. This one is particularly made on React. It is bundled together. Let me actually I have the code of it here as well. Let me get that in front. Okay, no worries. But essentially, this one is packed through React. I have the link here. It's packed through React, bundled through web. Guys. Yes. So this is the game source code. We can check out the packages and see what it is using and how it is working. So essentially, what they did was is they made a plain React project. Since 3JS is provided as a module on React as well, and they are using something called VITE. This is another module I found that which particularly helps us maintain and set up environments as big as, for example, this racing. So for smaller projects or like smaller websites, it's not really a big deal, and I was able to handle it in a single HTML app. Not as good, but great, workable. Even in React, basically, it was fine. But for projects as big, I saw the number of files that they had simply for audios was crazy. So if we go into the assets and check out what they have some blend files. So these are those Blender, if you've heard of the name, software's name, the 3D software. The files from those are directly consumable in Three.JS. So it is able to consume a lot of actually many other apps as well for 3D rendering applications. So it's this is one another example of bigger projects that happen there. This is one of my personal favorites. So this is a different kind of orbital controls that these people have used. So this is basically reacting to the position of the mouse and making the camera move in a kind of mathematical formula way to create a parallax effect. And this is entirely done by kudos to Baron wherever he is. I personally loved it and it was beautiful to look at. Sometimes I just let it open and be here as my screensaver at night because it looks glorious, honestly. So another couple of great shout outs to these people. Let's go back to our earlier document and see what else we have. So, this aviator, another one is this flying carrot, guys. So, this is another example of infinite kind of workspaces that we could make. So, a couple of websites have done this, especially I would say car companies are doing this, where they start on an empty scene or sand area, they place their car in the middle. By default, it is accelerating at a certain pace, and it will just keep going and keep the camera will keep rotating a little bit every a few minutes, so as to create the illusion of a video. And if you try to press any of the arrow keys, the car immediately responds to your keys and starts moving around that way. So it's a beautiful surprise, I would say, for the consumer is what I personally loved about it, and is the sense I want to use it in my project. But again, there would be n number of use cases I'm sure we could find. I hope any of them fulfill this. That's all. So this is another example of an infinite one, which also has a different feature that I like. So this had a scroll-based event listener, which was allowing to zoom in or zoom out of the object. So a simple scroll would zoom in wherever it is in that same 3D space. And if you see now the clouds, as they go further away, they become smaller. And if we don't use the perspective camera, that would not happen. It would look like much flatter. In sense, the sides, the back parts would be slightly pers- bent over and shown the sides of it. So it looks odd. It is not usually, personally, I have not seen a lot of projects using it, to be honest, and I stuck to it myself. Another fun example was this aviator one, which was actually sticking to the mouse again and making it into a game, collecting stats of what you bump into, what you collect. And it was fun ways to interact and make a small website. So personally, I was looking on of ways to fill up my website in different ways, and I have been bombarded with so many ideas that I'm not sure what I want to do. But this is a repository of what I have collected. So this thing it keeps getting faster as it goes on, and that is beautiful. I loved how many surprises there can be while you're interacting in the same page without scrolling, without taking the person's attention away, basically, without having to change pages, refresh, navigate. It's fun, and that is what I just wanted to share with you all. The fun part of it. So another one that I really like that I would like to share with you guys is let's go towards that advanced starter kit. So let's try to run a project. See, so I have this another project here. Awesome, we are already in it. So very quickly let me begin that. So this one I really like because the resources. I'll try to share a couple of YouTube videos that help me make these particular small projects that I have made with me, and I feel those would be personally helpful. This is one of those which essentially helps us render a plane and helps us render a character, a 3D character, and then interact with it. So basically, this 3D character, as this guy mentioned in his video, he collected from the Three.JS website itself. So a couple of different add-ons that they provide with the even with the a common shared repository of resources is animations, which I really love. So personally, this character when you download that character, it has certain things called animations itself in it, and all you have to do is hook those up and you're done. So, for example, this particular app responds to these four keys. What they have done is they have written a character control class, which actually, if you guys are able to check out the code for this on your end, let me share the link of the source code so that you can check it out on your site. On the same page, if we go, you'd be able to find it. Oh, apologies, it's not here. Let me actually share the link for this separately with you guys. Apologies for that. Basically, it's a character controller that they have written, and they have set up a walk animation, a walk function, a idle function, and a certain transition phase that is there. So basically, what they are doing is they have different frames of the character standing and in the running phase, and in the intermediate frames that they have collected, they smoothly swap with each other. So smoothly fade in and fade out and fade in and fade out, and try to give that walking effect. So in essence, that character is not really walking, but those animations at 60 FPS are changing and giving you fresh frames so that it looks like that is happening. And what the other thing that is happening is the camera is moving with the character. So otherwise, if you'd see in earlier projects, whenever the characters were moving, was not necessarily that it happens. So this character movement is also basis the event listener. So with whatever event listener we have for W arrow key, for example, in that itself, we are writing that once you have the new location of the character, you also update the camera key, follow that character and maintain your minimum distance from it, which essentially lets us create this third person FPS kind of feeling for it. Another couple of things was, so for example, another animation that this thing provided was running and walking as separate. So shift, I think, is the toggle here. So this is the walk state for it. Again, a set of animations that are provided by Three.JS, which we are just fading in and fading out on our leisure at our step. So if we try to check out the code, what is happening here and how this is happening actually. So let's see, we have some boilerplates and we have this advanced script. In this, we have this one is particularly written in TypeScript, and we have a source file here. So as we have previously done, it is also similarly setting up the things for us, but this time we are using three as a module instead of a CDA. So this particular is a React project written in TypeScript, and it has all of the resources of models and textures and everything else in this SRC folder. The main handling is happening at the TS file, which is the Three.js part of it, is happening in this file. We're setting up a simple scene. We're setting up a background. We're setting up a perspective camera again. This 45-degree is the field of view actually. The first parameter is the field of view. This is the aspect ratio of your screen. So whatever this is, whatever the initial state of the window is, the camera is set at. But so that it can keep updating basis the window is why we set that on resize hook that we did for that event listener. So this is that aspect ratio which takes as a second parameter. All of this is mentioned in the constructor itself. And this is what we remember as the near clip plane and the far clip plane as to what will be rendered, the definition of the section of that screen. So for this project, it has set it up very near to the object and as much as it can render until the end, which is why we're able to see the background, the sand stops at one point, which is I think 1000. But post that, the character I think still can walk if I remember correctly. But let's see, I don't remember the picture. It can still work, but the sand texture ends at that point, so it will not appear as real as it would. So essentially, the camera is set up, a renderer is set up as we did, and what we have here is the orbital controls, which is essentially helping us maintain a distance. So there are many uses for the orbital controls. As I showed, there was some interacting in making the parallax effect, and this is another use case to make it an FPS kind of effect. This guy was smart. He made a lights function and it's initiating all of the lights for us. We'll check that out wherever it comes. A floor function, which is essentially taking up the sand textures. So how we have that sand texture is a texture loader takes it up and sets it up in the size that you define in the plane that you define. So there are a couple of other things as also I would like to add. So in this, there are a couple of words that you would come across as well. So there is a mesh, there is a material, and there is a fabric. Let's try to use an analogy to understand. So basically, if you are trying to generate a sphere, for example, as simple as that, uh, similar to creating that in real life, it would need to have some kind of physical structure, a frame to it. I would say we could call that as the geometry that is the equivalent term in Three.js for it. Once that frame is there, it obviously can't be just outline. It has to have some kind of texture on top of it so that it looks like a whole object instead of a hollow one. So for that, there is a material on top that can be consumed via files, different kinds of files that are supported on this platform. And then there is a third thing that is in this context called as the mesh. So how they have explained it is the geometry is the basic infrastructure and the outline of it, The material is the outermost appearance part of it, and mesh is what binds it together to create a whole effect. So if I am actually not a design person, I don't have file access, like I don't know how to open these files that they have given for the Three.JS character, this one. But the file that comes, apparently, the people I read about on Reddit, they mentioned that they were able to unbundle it to see individual frames and the skeletons and the materials of this character itself. So every single thing from his arm to his, every single thing is coming as a panel itself, and then it is getting stitched together. How it is done is beautiful, and I personally exploring with a couple of design friends as to how I can make another custom material or character of my own if I wanted to, and how easy would that be. So let's see if how that goes and if I can share that with you guys in future. But this is so far one of the most brilliant ways I have found to fill up a web page, and I just wanted to share it with you guys. So this one particularly stops here. I would just open this. Once the lighting is done, it also has this animation function for this particular project as well. Let me just very quickly open it. We're checking out. Yes. So we have those orbital controls, we have those lights, we have set up the flows, and now we have that character basically. So how this comes is a GLB file. It is a standard that they have accepted for 3D files. This particular file that I got had the animations inside it, which was I think gltf.animations as well. So this gltf file that we are loading has the animations, and we are loading it to an animation clip where basically each name of each frame is the object's key and the value is the animation itself, the frame itself. And basically what we are doing is we are just passing the inbuilt functions, which are the clips and the mixers. Clips is essentially the whole array of images that can be rendered to make animation from idle to running, for example. And mixer is basically what does that animation for from that clip. So we're just letting that handle on itself. We loaded this particular thing from our resources. So this is that file over here. And we are we'll be calling up hooks to make those transitions. Here we have just loaded the character for now. This is the part where we are doing the control spaces basic. For example, key up, key down, what has to be displayed, what event has to be done, what kind of, so these are functions that this person has written on his project. And honestly, he explains it in such great eloquency that I would be feeling bad if I tried to do that. So I'll just share the link of that YouTube video, and I would urge, if you guys are interested in it, do check that guy out. He is doing things brilliant. So what he has done is he simple set up a couple of event hook listeners here, and then he has written a character controls function separately, which is a couple of initial values for the things and a couple of transition functions towards the end of it. So basically one function to update the state. Basically any transition, once the transition has happened, it needs to be communicated that it has ended. So that particular part is handled. A switch basically, and a couple of actual animations. So for example, if it is running, what would be happening? If it is walking, what would be happening? A lot of things got quite mathematical for me personally. So I'm still learning about this, but I have been seeing a lot of mathematics being used in this sense, and I feel it only makes sense since we are trying to almost replicate a director kind of an experience as well. So that is another point that I will share. Coming back to our index file, next up, once our animations are ready, once our soldier is loaded and our keys are also set up to react in a certain way, we have this animation function again, like we discussed, and again a beautiful on resize hook, which makes sure that the window is not crapping out, and beautifully loaded textures, everything. So basically, there are two main sections. One is the initialization part of it, and one is the animation part. Initialization includes everything from what the scene is, what it would look like, initial positions, what kind of interactions are there, all of it. And then there is the animation which keeps running at 60 FPS. So we have to make sure that it is light, because I was in my couple of starting projects, I made it very heavy and it was trying to render at 60 FPS, but only able to render about 20 to 23 FPS. And the rest of that just kept getting added to the bulk queue, and it was just crashing out eventually very soon. So a small thing to keep in mind, I guess. So again, the lights that we see for this one. So what it has is one ambient light and a couple of directional lights specifically adjusting the shadows. So there are a couple of advanced projects that I found. So let me open this one. There is there is one that is a portfolio, but that is that is using shaders, for example, to make those animations. Check this one out. This is called the displacement scroll, and essentially, this is an interaction based on the scroll itself. But on scroll, it will take two frames and fade those out in a certain animation. So let's check this out. So if I do a single scroll, it will one, two, three scrolls make the animation fade. And if we keep scrolling, it is just brilliant how these smaller animations can be done with so much ease. And all this guy is doing is using, again, not even a React project. It's as simple as a small project. And he has certain accelerators on touch start and keeps increasing until three wheel count is done. And it's amazing. It's amazing how beautifully people have been thinking about this and the possibilities of it. So another beautiful website I would like to add is this turbulent one. I have shown it to everybody I know, and it is one of the best animations I have seen. And this is where I aspire to be personally on Three.JS. So if you open this up, it's called turbulent.ce. I'll drop a link for this. And this one is basically a combination, basically a real world use case of those scroll based animations and a real website merged together to present a beautiful experience for the consumer. So initially, the page starts with this position. It's obviously responding to that parallax kind of effect. And as we keep scrolling, basically, there are animations set on scroll. So the camera is moving a little bit slowly as we scroll, and other animations are hooked to that scroll as well. And if I start from the top, let's see how that goes. Beautiful use of lighting on this one as well. So as we scroll, the header fades away and the ball starts animating. And they move on to another section of their portfolio. I would suggest you guys open it on your side. It's a little bit laggy for me because I have a really lot of things open on my laptop. But as we go on, it moves into the particular scene that it has created. And then it will move on to a different scene, which is the rest of the information, which is what I really loved. The transition from that interactive immersiveness to a standard part of the information that is equally important to be shared. And they transition into a couple of other projects that they have done. The Star Trek one was beautiful. To check that out and about themselves, and that's the end of towards the end of the website. And how they did it is actually something that really intrigued me, to be very honest. And this kind of blend between those two things, brilliant use case. I hope InMobi or any of you guys have any kind of use cases of this kind of thing, and we are able to see something in action. I hope this is just a small push towards that. Hopefully, that's about it from my guys. If you guys have any questions, I'm happy to answer. I'm available on chat, on DM me on this group, anywhere. Happy to share whatever I know. I have shared this resource guide with you guys. I'll also be sharing that starter sample thing and the two starter projects, which are the character interaction and the other one. And that's all from my side, guys.